Welcome. In this video we will be looking at lipids and some of their properties. So by the end of this video you should be able to define lipids and describe their structure. You'll find that they come in a variety of structures. You'll want to be able to differentiate between or among the types that we talk about. You will also want to be able to identify nutritional sources, describe the role that fats play in the body. We'll talk about cholesterol, a special type of lipid, and some of its functions in the body, and you should be able to differentiate between cholesterol and lipoproteins. And finally, we've talked about the dietary recommendations as they pertain to lipids. We'll refresh those, and you should be able to recall those later. So lipids are organic compounds, organic meaning they're made up of carbon mostly as the backbone. They are different than many others in that they're insoluble, so a lot of the bonds in lipids are carbon-hydrogen bonds, which are nonpolar, which leads to a structure that's non-soluble in water. There's four main types that we will be talking about: the triglycerides, and free fatty acids, phospholipids, and sterols. We'll start off talking about fatty acids, since these actually will make up two, or be a component of two of the other ones that we'll talk about. So fatty acids are made up of a hydrocarbon tail. So that's what this structure over here is. It's called a hydrocarbon because it's made up of carbon and hydrogen atoms. So each little end to these lines represents a carbon atom with the number of hydrogens coming off from that carbon atom. On the end of the fatty acid are the carboxylic acid heads, so that's what this structure over here represents. This OH and double bond O with a carbon linking the two. Now when we talk about fatty acids, you'll hear terms such as saturated, monounsaturated, polyunsaturated, and what that is referring to is the number of hydrogens that the fatty acid tails are holding. So a saturated fatty acid has a tail with all of the hydrogens that it can hold. So that's what's represented in this structure up here. And unsaturated fatty acid will have a double bond in here, which represents hydrogens that could be added into it. So this unsaturated fatty acid here can have two hydrogens added to it. So if it only has one double bond, it's referred to as a monounsaturated. If it has more than just one, then it's referred to as a polyunsaturated fatty acid. Another thing that you'll commonly hear as it pertains to fatty acids are omega numbers. So the omega represents the distance from the end. So omega-3 would be, this was the first carbon, this would be the second, this would be the third. This was omega-3 fatty acid. It would have a double bond here, so it would be unsaturated in this regard. But because this is saturated, you'd have to keep counting, or because this is just a regular bond, you keep counting. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is an omega-9 fatty acid. Now triglycerides are actually made up of 3 fatty acids bonded to a glycerol backbone. So that's what this 3 carbon groups here. Normally glycerol has a hydrogen that's attached here to it, but when the fatty acids are added, you lose the hydrogen, so it's got an oxygen that's linking these. And so it's called a tri because they're fatty acid. There are 3 fatty acids that are attached to it. The glycerol then is this part of it. This is a substantial way in which the fatty acids are stored in your body. and is a substantial source of fatty acids within the foods that we consume as well. Now, if you were to take one of these fatty acids and replace it with a group known as a phosphate group, you would end up with a phospholipid. So a phospholipid is basically a modified triglyceride where has a hydrophilic head and hydrophobic tails. Hydrophobic tails means that it's water-fearing or it doesn't dissolve in water, so that's going to be nonpolar substances that make it up. The hydrophilic head is attracted to water, so it dissolves in water, and so the head out here will interact with aqueous solutions. So phospholipids are what make up our cellular membranes. They're made up of a phospholipid bilayer with the fatty acids, the phospholipids facing each other with the heads on the out, tails on the inside, and so this prevents a barrier that represents the inside of the cell and the outside of the cell there. Now, this brings us to the topic of essential fatty acids. So there are actually 2 essential fatty acids that we must get from our diet. Other fatty acids we can actually make either from these or from other components. So these 2 essential fatty acids are, one is an omega-3 fatty acid, so you can see that here, 1, 2, 3, and then you have a double bond. The other one is an omega-6 fatty acid, so 1, 2, 3, 4, 5, 6. So alpha-linolenic acid, you'll find this in flax seeds and walnuts, other things as well, but it's an omega-3 fatty acid that's essential, meaning our body can't make it. Omega-6 you'll find in most vegetable oils, most seeds. Again, our body can't make these. Our body balances these 2, one of them being pro-inflammatory, the other being anti-inflammatory. They have a lot of other functions as well. Now, when we look at alpha-linolenic acid, our body actually doesn't use a whole lot of this as is. It actually needs to convert it to either EPA or DHA, which are different omega-3 fatty acids. Now, our bodies can't make these either, but because they can actually synthesize it to a certain degree from the alpha-linolenic, these are not considered essential. However, there is debate whether our body actually makes enough of either of these from this, with a lot of people saying that it doesn't, so you actually should consume some of the EPA and DHAs as well. Now, one thing that we haven't talked about are the trans fatty acids. So trans fatty acids are mostly non-natural artificial fats. There are a few ones that are natural, but these are rare. Most of the trans fatty acids comes from the process of hydrogenating our oils. They do this to make the oils more stable so that it increases their shelf life. It also makes the liquid oils more solid so that they can be used in things such as frying and as margarine. So trans fatty acids are referring to how the double bond is structured. So you'll notice here that the double bond can be structured so that you have the carbon chains essentially being extended on the same side, or you can see that they can be on the different sides. So here it's going up, here it's going down. So if they're on the same side, this is actually a cis fatty acid. These are how most of the unsaturated fatty acids are naturally, and this provides a kink in the chain, which actually makes it more likely to be liquid at room temperature than if it is trans, which is this structure down here in the middle, which leads to a strong chain that can pack tightly together. It tends to be more solid. Saturated fatty acids can also pack very much like the trans fatty acids that can be packed together. We'll talk about these in more detail later, but trans fatty acids are thought to be particularly bad for your health. So where do we get our fats from? Well, they come from a variety of different areas. So oils are fats that tend to be liquid at room temperature, while when we say are lipids that tend to be liquid at room temperature, while fats tend to be solid at room temperature. So when you hear about the oils, you're usually hearing about the canola oil, corn oil, vegetable oils, etc. Now there are two, our oils tend to be mostly polyunsaturated, as you can see from this, either polyunsaturated or monounsaturated, and not have a whole lot of saturated fatty acids. It's really the saturated fatty acids that lead fats to be solid at room temperature. Now there are exceptions to this. Palm oil and coconut oil, for example, coconut oil especially, actually does have a lot of saturated fatty acids, which is part of the reason why it actually has a melting point that is a little bit higher than the oil. So you can actually have coconut oil, you can find that to be about liquid at room temperature. Dairy, you'll find a lot of the saturated fatty acids in this, especially the whole milks, the creams, and cheeses. Meats can have a lot of it, varying based on the cut of meat as well as what type of meat it is. You'll notice that a lot of these have a lot more saturated fats. Not a ton of polyunsaturated fatty acids, but there are significant ones when you get down here to the salmon. That's where your omega-3, DHA, EPA fatty acids come from. And of course you have those that are added during the cooking method. You have lots of ones that are added in sweets and baked goods. These are sometimes, you miss them because you don't actually see them like you do with all these other fats that you add, like the beef fat, the lard, etc. Nuts are also high in fat. They're high in fiber and other nutrients as well. These fats tend to be mostly unsaturated, with varying degrees of the types. Macadamia nuts, you'll notice, have a lot of the monounsaturated, while walnuts will have a lot of the polyunsaturated fatty acids. The one type of lipid that we haven't really talked about yet is cholesterol. So cholesterol is made up of a sterile backbone. This is the structure of it. On one of the earlier slides you saw the sterile backbone that was really making it up. It's found in animal foods. It's not an essential nutrient because our body can actually make it. We will talk later about how cholesterol, dietary cholesterol plays a role in your health, and to what degree that actually plays a role in your health. But obviously cholesterol you've heard associated with cardiovascular disease, and it also has a lot of important functions within the body as well, serving as precursor molecules to the sex hormones. It's what's used to synthesize bile and vitamin D. So it has a lot of important functions. It's an important component of cellular membranes. So cholesterol is a very important molecule in that it does play very important roles within the body. And we'll go into more detail about this at a later time. Now, cholesterol is actually carried within lipoproteins. So when you hear about the good cholesterol and bad cholesterol, they're actually talking about the lipoproteins which carry the cholesterol with it. There are three major types of lipoproteins. There's the VLDL, the LDL, and the HDL. So the VLDL stands for very low density lipoproteins. This means that it's made up of more lipids and less fats. Or more lipids and less protein component. The LDL is low density, HDL is high density. So LDL is going to be made up of more lipids. The HDL is going to be made up of more proteins, and it's considered the good cholesterol because it's associated with healthier health outcomes. Now, this is a very simplified view of this, but VLDL and LDL tend to carry cholesterol from your liver or as a component of food out to the tissues, and it can kind of get stuck in the blood vessels, and that's when it can kind of cause problems. While HDL is kind of thought of as something that brings the cholesterol back to the body and actually fixes it from there. Again, this is a very simplified version of what's going on here, and it's really beyond the scope of the class to really go into this into huge detail, but we'll address this at a later time in the class. So the function of lipids in the body, of course, fat is a good energy source, provides 9 calories per gram, so that is something that you should definitely know, is how many calories per gram are in fat cells. In the body, it's the main way that we store our energy. We use it for padding and insulation, so it cushions some of our joints and other tissues in our body, so it provides a way of keeping us warm and keeping us safe. Phospholipids and other components such as cholesterol make up our cellular membranes, so that's one way that it's actually a building block. It's a building block in other ways. You use it just as a component of many different things within the body. It also plays a role as signaling molecules. So obviously the steroid hormones that are made from the cholesterol molecule, but also actually the fatty acids can actually serve as signaling molecules that are very important within your body as well. Of course, it's a nutrient and provides energy. It also carries nutrients with it. So within the food, the lipid-soluble vitamins, vitamin A, vitamin D, vitamin E, and vitamin K, are going to be need lipids to actually carry them in there. Of course, they're involved with flavor, texture, and satiety of our food as well. So what should we take in for it? So if you recall, the AMDR says that we should have 20 to 35% of our total calories from these. And of this, the saturated fat should make up less than 10% of the calories in an adequate diet. Trans fat, as little as possible, so you should eliminate this if possible, but it may not start causing problems until it becomes over 1%. It's not a essential nutrient. It doesn't provide us with anything that we need, so trans fat really isn't giving you any sort of benefit. Polyunsaturated fatty acids, so we mentioned that there were the two essential fatty acids. So linoleic acid should comprise 5 to 10% of the total calories, while linolenic acid should be between 0.6 and 1.2% of total calories. It is suggested that you should limit your cholesterol intake to less than 300 milligrams per day. Some people are more sensitive to this than others, and we'll address that later. So dietary guidelines say to keep trans fats as low as possible, to consume less than 10% of calories from saturated fats by replacing them with the monounsaturated and polyunsaturated fats or with other foods, And then solid fats you should replace with oils and low-fat foods, since solid fats can tend to have the saturated fats. So this is really a practical way of doing the previous step before it.